lesson is going to be recorded. And because it's going to be recorded, you can always go back and play anything that I mentioned about the syllabus or something that, if you want, I wonder what you said, I didn't pick it up. This is not what we're going to cover today. This is my list of what we're going to get covered in today, and Tuesday, I think, is the next day. But it gives me a little heads up so I keep things in track. So the first thing we're going to do is the syllabus, and I'm going to move over. And I'll get some chat. Should I know anything about that? Yeah, I'm cool. So let's do the syllabus. And that one, and make that go away. Right, are you looking, I hope, at our 163 Canvas site? Right. So in here, you're basically, there's two things in this class. There's the Canvas site and there's WebAssign. Canvas just basically has information, right? Things to help you, things you can look up, right? It's just a resource. And there's lots in it, lots of different things. On the other side, you've got WebAssign. And WebAssign is where you do your online homework, your online tests, and a whole load of things like that, right? So your day-to-day work is going to be done in WebAssign, right? Resources in Canvas. Right? So there's two kind of disparate parts to this course. Let's look at this one here first. If I click on the welcome one, which I'm doing here. Right, what this, I think I can make that a bit bigger, yeah. Right, what we have here is basically an intro to our class, and there's the technology that you need. You know, you do not need a textbook, so don't need to buy one if you haven't, because WebAssign has an electronic version of your textbook, so you can go and use that instead, right? If you want a textbook, that's your choice, but you don't need one. You do need a computer, a laptop, and all that good stuff. Well, I've mentioned that. To join our class, and that's a typo, that should say 264, but to join our class, you need to use our class key. Has anybody already joined this class in WebAssign yet? Right, did it go smooth? There was no hiccups? Right, so the information I gave you actually works, good. Right, what you've got here is a whole list of pages, how you do it, and you can look that up yourself. This probably won't work for you, but I'm putting it in anyway, because some of you may have a daytime class as well. I have an officer that's going to be 9 AM. Now, it probably won't work for a lot of you, so what I suggest is instead of that I'll typically start this class, you know, Zoom-wise, about 15 minutes early, and maybe you could ask me your questions then. If that doesn't work, you can wait at the end and ask me your questions, and we can, you know, that will be your officer. I think that would be more reasonable for you lot. If you have a little bit further on, this is the Zoom link for our class. It's a Monday, Tuesday, Thursday class. So I don't see you Wednesday or Friday, but it's roughly about an hour and a half in length. And here I listed all the kind of cool things you can get in Canvas. So if you want to find out anything like that, you can go to Canvas and just watch this particular one. Let's see if we can get back to home. There we go. Do a student view, that way it's a little bit more like what you would see. Right, click on this. Some information about me. I can tell you right now, you know I'm born in Scotland. That's kind of obvious. I was born in a place called Belsill, which is roughly, very roughly, halfway between Glasgow, which is the biggest city in Scotland, and Edinburgh, which is the capital city. They're both in the Central Valley. What else did I tell you? I'm one of 10 children. I'm number 8 in the list. My dad was a coal miner for all his working life. My oldest brother was a coal miner before he became a merchant navy person. All my uncles are coal miners, and all my uncles in my mum and my dad's side all my grandparents, the males, were coal miners as well. So essentially, I come from a coal mining family. And there are no more coal mines in Scotland. They're all gone. So go figure. So that was then, but this is now. I started teaching in August of 1980, which means I started teaching before, pretty sure, any of you were born. So that's how long I've been doing this job. Still don't know what I'm doing, but I have fun. So that's something. And I've already mentioned that. Jocelyn, listen, make sure whatever job you do, you enjoy doing it. Trust me, it's a good life. If you do something you don't like, it's a bad move. It really is. So seriously, take that into account. If you want the officer link, click on this. There it is. And oops, keeps going in and out for some reason. If you have trouble with Zoom, there's a page that has lots of videos and things you can use. If you're in trouble with WebAssign, there's another one. You don't really need to worry about this until the midterm. Basically, that's a piece of software that you can use to take pictures of your working and upload it so I can see it. I don't need that for normal day-to-day homework that's done in WebAssign. I don't need to or want to see the homework in those. But midterm and final, I do. That's just a fun one, which I think is kind of cool because I have a great sense of humor. Let's see if I can show you a really cool one. There. That is a Marine training, and this is a Scotsman training. Oh, come on, that's cool. It takes about 8 of your guys and 1 of our guys. Come on, is that not arrogance? If nothing else. That site is non-mathematical, by the way. It's just if you get stressed out and you just need a break from your English essays or whatever it is. There's some really fun videos. That one there about the Scottish Air Traffic Control is making fun of my accent, which I don't have. And that's an American who does a really cool lecture on his website. I love Blackadder, that's there. I love dogs, that's what that's there for. The elevator voice is another cool one, and you can watch them. It's really just for fun, nothing else. So I've kind of done that one. Now, I also have, oh, before I forget, this link here. I'll click on it right now. This is where your videos, including this one, is going to go. So when we finish this lesson, probably I won't be able to do it today, but I'll do it tomorrow sometime when I have time. I'll put the video here. So if you miss a day, you go here and you can watch the video for the day that you missed, right? So you won't miss anything in the long run. But I strongly suggest you come to class because it's important for your grade and for your learning. Right, now I think I finished that page. I've now got another one called class resources, and all the chapters that we're doing, chapter 11, chapter 10, I know it's slightly out of order, but that's how we're doing it, 11, 10, 12, and 13. Let's pick 12 at random. Here are the topics from chapter 12. If I click in this one, here are some videos, but these videos are not my videos. These are videos that I got on YouTube that I kind of liked because I thought, oh, that's a good way of describing it. So if I do something and it just doesn't click, because I know you can express something in 50 different ways, and 5 of them work and the other 45 make no sense to you, that kind of situation, that you might want to watch a video and say, oh, God, I get what he was getting at now, right? That's all it's there for. Don't need to watch them, but it's a resource for you, something else for you to help. Have all sorts of things in these resources. If I hit 13, and I scroll down to the bottom, if I got it in here. No, I don't. Depends on which chapter, what kind of resources I've got. Yeah, there's one. If you click on that, here's just some worked examples on some really heavy duty math. So just another resource. And at the bottom, we have a whole load of online graphing type calculators that you might use from time to time to help you with the graphic sections. And it's basically just a resource. And the last one is college resources, which is, you know, things that the college will do to help you. Any questions so far? You get a feel for Canvas is where you see stuff, right? And WebAssign is where you do your homework. So let's go into the syllabus proper. Most of what is here is repeated in other places, right? So nothing special. One thing I would mention to you that I haven't yet is you want to communicate with me, use my OC address, drobertson@olympic.edu, or do Canvas. Those ones I get right away. If you go into WebAssign, there's buttons like Ask My Professor or Ask for an Extension, things like that. And you might hit them and think, I'm going to get it, but I don't. And you might think I'm ignoring you. It's not that I'm ignoring you. I just don't get those messages. So don't hit the button because I won't see it, right? That's basically. Just email me, can I get an extension? Or email me, help me with question 4. And that I will see, and that I will try and help you with. Okay, you can't get to this class unless you've got a prerequisite. So hopefully you all have, and that's been done automatically. If you don't, you'll be dropped. There's all the equipment that you need. If you run short of a piece of equipment or you need it because your earphone, your mic's died, you can sometimes get a loaner off the IT people at college. There's the link. Go and click on it. You don't need a textbook unless you want one, because it's there's an online version of it. So I think that may be a good point for me to jump to, yeah. This is what Canvas looks like. Sorry, this is what WebAssign, I should say, looks like. There's our class. So let's jump right in. There's 11.1, one of your homeworks. Homeworks, by the way, are due every Sunday by midnight. That's the deadline, right? Get them finished by Sunday of midnight. So week 1 is going to be 11.1 and 11.2. So if you've never done WebAssign before, you basically get a question and you type in your answers. For instance, well, let me show you how this would work. A1 should be -4. So I'll do -4 and then I'll submit answer. And I got it right. And the next answer is not 678, but for some reason I thought it was. I'll submit answer. And oops. You got it right, you got it wrong. If you get it wrong, you simply just try again. I believe it's 3, and you submit answer. Now, can you imagine there might be calculator working to go with this, or paper scratch working to go with this? But the only thing WebAssign sees is what the final result is, right? The answer was 3 in this case, right? Now, you get 5 shots on every question. So when you've done all of these, so make sure you do all 5 before you do a submit, right? You get 5 shots to get them right. I think that's plenty. Someone went and asked me an interesting question that's never been asked before. Do you lose points if you don't get it right the first time? You know, like you get 5 points if you get it right, and then it's 4 points if you took another shot, and like 3. And no, if you take 5 shots, but you still get the answer right, you get the full points. So there isn't any reduced grading, right? It's if you get it right, you get the points. If you don't. Now, let's show you some of the other features if you've not done WebAssign. If you click on read it, it will take you to the ebook that deals with sequences, and it'll show you some examples and you can read it. If you click on practice another version, which I guess I'll do now, you see they give you another one, and you can, I'm just writing down randomness here because I have no imagination and I don't want to do the calculation anyway, right? There. You can hit grade this, and then you can say, show me the answer. And then you can say, show me how you done got that answer. So it kind of talks you through it, right? Or walks you through it, probably be a better way of phrasing it. So it's not just, here's a question, try your answer, and if you're right, I'll tell you. If it's wrong, I'm not. You see, they give you a lot of help. So your goal is to learn from your mistakes, which is how you learn anyway. Most people learn by what they did wrong. I can personally tell you that the biggest things that I've ever learned were from my mistakes, not from getting it right. It helps your brain figure things out. And that's pretty much what homework looks like. Can I hit home on this without it losing? Oh, good. Homework due midnight Sunday. Homework due midnight Sunday. Do you notice this third one, the homework is due not on Sunday, but next Sunday? I sometimes do an overlap like that because you can't really plan it to be exactly finished every section on Thursday, right? There's going to be half an hour left. So I'm not going to waste that time. I'll start the next section. And that means you can choose to do some of 11.3 to reduce your workload next time, right? So on and so forth. So that's why that's there. So pay attention to when it's due. So don't think that one is due because it's on the screen, right? It's due on the 17th, which is a whole week different. Now, what you won't see here yet is that, oh, well, actually, I've done enough. Let me show you on the other screen. I'll come back to that in a minute, but let me show you on Canvas again. Monday the 9th is a holiday. Monday the 9th is the midterm. Friday is a holiday, which really doesn't matter to you because you are not going to be here on Friday anyway, but it's there. And Monday is a holiday, right, which you will get off. And you are going to be doing I better check that. That says Wednesday. This class is a Monday, Tuesday, Thursday, isn't it? Let me check that one. It's still 5 to 8, but it won't be a Wednesday. I'll make an executive decision. It's going to be Thursday. It's either Tuesday or Thursday, so I'm picking Thursday. So it's going to be Thursday. And let's look at your calendar, your schedule. There are 11 weeks. Technically, there's 11 weeks anyway. Week 1, those 2 sections. And then there's an online test. You can spend as much time on those homeworks as you like, as long as you finish by Sunday. You can do 2 questions and then leave it for 4 days and come back and do the rest. Right? It's pretty much in and out when you have time. That's not true about tests. And there's 10 of them, 1 for each of the 10 real weeks. Whenever you hit the button to do test 1, which you won't see yet because I won't even put it online till Friday, right? So it's not a temptation that you shouldn't go into, right? When you hit that test, a clock starts ticking. You have got exactly 2 hours from when you click on it to do it. So make sure that you don't start any test until you're ready, right? I've done all the homework. I'm pretty sure I know what it's about. I'm ready to take my test, right? When you feel like that, then you click the button. You have 2 hours to do it. Go for it. I talked about extensions. This may be the place to do it. The drop dead date is Sunday, right? Every week it's a Sunday. You cannot get any extension to the test. If you haven't done it or finished it by the end of Sunday, it's gone. There are 10 tests. I dropped the bottom 2, so you can screw up twice, but that's the max, right? After that, it'll affect your grade. Homework, on the other hand, you can ask for an extension. You email me and say, I need more time, and I will give you it. It won't be a problem. I won't give you it at week 5 because you better be finished everything for the midterm. I'm not going to encourage you not to get ready for your midterm. And you won't get it at week 10, which is final. But all the others you can ask for an extension. And we'll tell you how that helps or hinders your grade later. There's week 2, there's week 3, 4, 5, and then you do the midterm. And the midterm's on Monday, and it's going to be 5 to 8. So it's a big long day. So make sure that you haven't got anything planned later in the day for that particular one. And the executive decision, that's going to be Thursday now. That's your final, and that'll be 3 hours as well. Now, all the homework and all the tests that you do, right, the typical day-to-day kind of stuff, they're all open book. You can, you know, like practice another, help me do, you know, all that stuff. None wrong with that. Go for it. And when you do the tests, pretty much open book as well, right? Don't cheat. Cheating is kind of obvious, right? Ismail, I don't know this, I'm pretending I do, but did you know that Ismail has a twin brother? And he's just going to let his twin brother do it. And Jocelyn's going to phone her sister and she's going to tell her all the answers, right? We know that's cheating, right? Now, I can't go through a list of every way you can cheat, right? Because there's probably quite imaginative ones I could never think of. Open book, if you've physically written it down, you can use it, right? But you can't phone a friend, get somebody else to do it, or any of the other 101 ways you could cheat, right? I'm not going to be able to check on that, but I'm doing it as I expect that from you, right? That's the only way to do these things. And carrying on then. What's different about the midterm? Midterm's going to be like this class. It's not going to be online. It's going to be in a web. It's going to be in Canvas, and it's not going to be in WebAssign. And it's going to be a PDF. And you're going to write all the answers down on paper and show me you're working. And then you're going to upload it and I'm going to see it. So that kind of makes you, or hopefully forces you into making sure you understand what you've been doing in the last 5 weeks. Because if you've just been, you know, finding answers or keep hitting buttons till you get lucky and you get the right one out of your 5 guesses, that's not going to bode well for that exam, or for that matter, the final. Are we good so far? I told you tons of information, but, you know, pick up what you can. These are the cool things you're going to learn in Calc 3. Don't cheat, which is that one. If you have some accommodation, tell me about it. And let's talk about how you get your grade. Mandatory attendance, you get 10% for turning up. How do you get 10%? Well, in your case, every single day gets you a participation point. So Kira, you've already got 1 participation point, right? Another 29 to go. You also get participation points, 1 a week, if you don't ask for an extension. So in other words, if you do your homework on time and you don't ask for extra time, you get an extra +1 on that. Technically, that means that you could get 133% on participation, right? Right, so you could actually get an extra 3% added onto your grade just by being, you know, on top of things and doing it right. And that adds up to 10% of your grade. Homework, 20% of your grade. Online tests, also 20% of your grade. So you want to make sure that when you do your online, you're ready. Now, I mentioned before, I'll mention again, the bottom 2 get dropped, right? So midterm exam, 20%, final exam, 30%. So that's how it's all going to work. It all gets put together and depends on what your overall percentage is. This is your grade. So for instance, to pass this class, you need to get at least a 75%. Right? That's a 2.0. If you want a 4.0, you need to get 95%. That's what your thing looks like if you want to see a letter grade of it. Right, extra help. We do have tutoring. For you lot, it's probably going to be e-tutoring. Right, so you go to Olympic College, you go to the tutoring thing, and I believe you just click a button and you go into a queue, and somebody in Kansas, or if you're lucky, Texas, will help you. Right. Thomas, you're nodding. Have you used the e-tutoring service yet?
I have before for some, yeah.
Oh, yeah.
My brother works for it.
Oh, well, so it works pretty smoothly.
What was that?
It's pretty easy to use. It
Yeah,
works
it's pretty easy.
smooth. Right. So, you know, do it. That's a resource. When I say see me, I'm really not talking about physically seeing me. I think my wife would have problems about students coming to our door. So what we're really talking about is see me during office hour, or shoot me an email or something like that. It's helpful if you can tell me a little bit of detail about your question. So for instance, tell me I'm having trouble with question 7 from section 11.4, right? That is very helpful, because then I can go in and I can look. I can actually look at your attempts at that question, so I can help you more that way. Canvas, lots of resources there. WebAssign was showing you lots of things they can do for you as well. So there's plenty of things here. Last thing, general advice. Do not do your homework at 5 p.m. on a Sunday. It's not a good idea, because if you can't do anything, it's too late to ask for help, isn't it? I can't fix it if it's too late. Don't do it. And seek help as soon as you can, right? Fix things quickly. This is more to do with, before the midterm and the final, they're worth a lot of percentage. Try and figure out some way to get extra time off, or at least prepare to give yourself a lot of chunk of time, because it will be a lot of work to revise, right? 5 weeks and then the final 10 weeks. And you need as much time as you can. So try and organize and plan your time efficiently. And there's the usual kind of things that the college mentions. Whew. Oh, I'm so glad that's over. Is there any more questions? Can we get started on the cool stuff now? Yeah, good. Right, so let's zoom over. Oh, an inverted shot. Caitlin, I just noticed you. When did I get you last time, Caitlin?
That was fall quarter.
I'm not too far away.
Yeah.
Okay, let's give you a kind of list. This is kind of for me as well as for you, right? Check. So we are going to be starting our first section now. And what we're going to be looking at, if I can move this over here, is we're going to deal with section 11, chapter 11, section 1, so 11.1. Kind of warm up to that. Calc 1 was all about how do you differentiate things and what can you do with them? Very basic. Calc 2 was how do you integrate things and what can you do with them? So you might think, what on earth is Calc 3 going to be about? You're not going to like this answer. Calc 3 is not about one thing. Calc 3 is where we put all the other stuff that's important, but we didn't have time or able to put it in the other two sections. So you are going to find that we are going to be doing chapter 11, which is sequences and series, and then chapter 10, which is parametric equations, and later on we're going to be doing vectors, and then finally we're going to finish with partial differentiation. And you're going to say to yourself, what is the connection between all those things? And the short answer is there's none. So don't try and find the connection. Just treat them as little bunches of information that are useful and we like you to know about them. But sequences and series has nothing to do with three-dimensional vectors, right? You won't be able to find any, oh, I can see why you needed that to learn how to do this. It's not that kind of sequential thing that you're very used to in math, right? So I'm putting that out there so that you don't start thinking, this doesn't seem to be cohesive, because the answer is you're right, it's not. I could, if I wanted to, take every single chapter that we're going to do, shuffle them, and do them in the order it came out, and it would have no effect on your learning, right? That's how unconnected they are, right? But why do I pick this one? Because it's the worst one. It's the hardest one, and it's the longest one. But if you survive this one, most people will tell you the stuff that comes after is easier, right? So warning you up front, this is the killer, right? This is the one that's going to get your brain hurt, hopefully in a nice way. So let's start off with a sequence, because that's what 11.1 is about. It's about sequences. Well, a sequence is a list of numbers which have a pattern. So an example of a sequence, and there's tons of sequences in the world, in nature. But here's an example of a very simple sequence. These numbers are not random, right? It's a list of numbers, 1, 4, 9, 16, and 25. They have a pattern to them, don't they? Can anybody see the pattern? And the way you can kind of prove to me that you can see what the pattern is, what would the next number in this sequence be equal to?
36.
Okay. Let's put you under pressure. What would the next one be?
49.
Does anybody see the pattern that he sees? Because he's getting them right. What in heck is going on in this sequence? How do you know that that's 36? How do you know that one's 49? How do you know the next one, for instance, is 81? How do we know that? Yeah.
Can I say it is every number is just squared up?
Yeah, you could. I would agree with you. So this is a sequence. Sequences are an infinite list of numbers. In other words, can't this sequence go on to eternity? There's no end to it. That's one of the features of sequence. So let's introduce you to some very common notation. You'll see notation that looks like this: a little 1, a little 2, a little 3, a little 4. A1 is the first number in the sequence. A2 is the second number in the sequence. A3 is the third number in the sequence. And A4 is the fourth number in the sequence. And you can imagine I continue that forever, right? So when we write down a sequence, it's very often going to be the case that we describe the entire sequence by using a formula. And the formula very often looks like this: AN equals. Now let's see if we can, you've kind of already told me what the answer is by the way you phrased it, but I'm going to just pretend that you hadn't. The first number, the second number, the third number, the fourth number, the fifth number in the sequence, the sixth number, the seventh number. What would the nth number be? Tell me a formula for it.
N squared.
I hear it. I hear n squared. Would you agree? So in this particular sequence, we would describe it by the formula an equals n squared. In other words, isn't the entire information that's written here condensed into a very simple formula? You might ask, and it's a good question, but you won't like my answer, why is it called AN and not BN or CN or DN? Well, actually, you can use any letter of the alphabet you like, but how about A is the first letter of the alphabet, so we'll use it. No significance apart from that, right? So if you're wondering why it's A, it's because it's the first letter of the alphabet. Nothing very interesting about that. Now, if you have a sequence in its formula, is there other ways that it's written? Well, one of the ways is you basically just write down that sequence, not this piece, and put ... And you put these funny, I call them curly brackets. You can also do it like this. In some textbooks, you'll find that they write this down. Or more likely, they'll write it like this. Can you see that this notation and this one here are essentially telling you the same thing? It's just written in different ways. So an equals n squared. Do you agree that's the sequence? We already decided that. Wouldn't this one just be a generic sequence with no formula attached to it? And wouldn't this one be a specific one, which is actually this guy again? So that just showing you the different notation that you can see being used to describe a sequence. So what are some of the questions you're going to be asked? Well, let's look at the first type of question. How do you find their values? Probably one of the easiest things. Suppose I have a sequence and it's n cubed plus 1 over n squared, right? Okay, that's my sequence. And I would like to know, as they very often do in a lot of your homework questions, I would like to know the first 5 terms of that sequence. Now, I could simply do them in my head. Couldn't I just say, okay, A1, 1 cubed plus 1 over 1 squared. A2, 2 cubed plus 1 over 2 squared, right? A3, 3 cubed plus 1 over 3 squared, and so on, right? And yeah, I could probably do that. I'll try it anyway. 1 cubed plus 1 over 1 squared ends up being whole number 2. 8 plus 1 is 9 over 4. A3 is 28 over 9. A4, 65 over 16. And lastly, A5 is 126 over 25. Will you just trust that I did that right? And if I didn't, you can fix it yourself there. Now, a couple of things about this. We want exact values. And we typically want values that don't have decimals. We don't really like decimals in math. I know engineers love decimals, but we don't. So fractions, even if they're ugly fractions, would be considered the better version of the answer. But let's pretend this formula is something ridiculously ugly that I don't want to have to do 5 different times. Is there another way we can do it? The answer is yes. Your TI-84 can do sequences for you. Right. Let me show you how you do it. You go into y equals and you clear it out. Let's pretend that that's the question, right? So I'm just going to use this as an example, right? But can you imagine this could be really ugly? Right? So I'm going to do a bracket. I'm going to do x cubed because I can't do n. I'm going to go plus 1, close the brackets, and then I'm going to divide by x squared. So basically, don't you just type this thing into your calculator as y1. So that's your first step. Then go second table set. And you see this guy here, table setup? Start at 1. That's basically going to tell it to start there. Make sure it goes up in ones, which this one is. And lastly, make sure that says ASCII. And that's you pretty much done. Now, if you've got that set up, all you need to do now is second table. And this is stuff I don't want. And I am now going to put in 1, 2, 3, 4, 5. Now, do you notice that all those answers are horrible decimals, and I don't want decimals? Right? Well, I could make them fractions. Let's pick one. 2.25. Oops, clear that out of the way. 2.25. 2.25. Math button. Choice number 1, fractions. There's my 9/4. Right, so if some of the answers come out ugly, can't you just write them down and then come back out here and turn them into fractions? Are we good? Now, if I go back to that table, I don't actually need to get all the numbers. For instance, if I wanted to find what the 10th number is, don't I just type in 10? If I wanted to know the 100th number in the sequence, I'd do that. If I wanted to know, I don't know, I'll try and break it. There, that guy. Oh, I got an answer. And so when this is set up, can't you find any number you want, right? If you want to know the 83rd number in the sequence, you could do it. Any questions so far? So if I give you, or if WebAssign gives you a sequence and they ask you for the first 5 terms, do you feel comfortable you know how to do it? Right. Okay, that's good. So, oops. That's basically those two guys covered. Now, there are 2 kinds of ways to generate formulas for sequences. The one that we've just done is implicit. That's where you write down, you know, that kind of guy, right? The next one, number 4, is a recursive relation sequence. Now, those, you can't really do them the shortcut way, right? You can't really use a calculator to do them all. You have to kind of do them one at a time. And I'll show you what it looks like. This is one example of it. And it has a very specific format. This says the next number in the sequence. Think of it as saying the next number in the sequence. It's 0.1, the previous number plus 5. So let me set up my sequence. There's 10, my first number, right? Now, how do I get A2? Well, A2 is nothing 0.1 times him, add 5. So that ends up being 6. Now, how do I get A3? Nothing 0.1 times this, add 5. 5.6. How do I get A4? Isn't it nothing 0.1 times the previous guy, add 5? So that's going to be 5.56. You can see where I'm going with this? Right. Previous answer times 0.1, then you add 5, at least in this case. One last one then is that one. If you do that, you get 5.5. What do you get? 5.556 and forever. And then if I put little curly brackets around it and a dot, 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 haven't I basically completed the first 5 terms in a sequence? But isn't there no shortcut? If I want to find A5, don't I have to find A1, 2, 3, and 4 before I can find A5, right? There isn't a way of bypassing that. If I said to you, what is A1000? Caitlin, you would leave this class and say, I'm not for coming back, because wouldn't A1000 take you a couple of years or a couple of days? I don't know, it'd take you forever, right? So if anybody ever done that, wouldn't it be a computer program? Wouldn't you just set up a computer program and say, okay, find the 1000th term. I want to know, who knows why, but I want to know. Now, that's only one example. Here is another one. Also a recursive relation. These guys here are very often called, well, depends on the textbook. They're sometimes called initial values. They're sometimes called seed values, right? They're the thing that starts it growing, right? It grows from its seeds. I guess that's why they call it a seed value. Initial value makes sense, right? It's a starting value, initial value. Now, in this case here, A1, A2, A3, A4, and let's finish with A5. Well, I'll change colors now. I already know what that guy is and what that guy is because you told me, right? They could have told me it was 1 in 20, couldn't they? But they told me it was 1 in 1. Now, how do you get A3? Well, the next number in the sequence is the previous number plus the one before that. You see how this is working? The next number is the previous number plus one before it. So this next number, A3, won't it be that guy plus that guy? 2. Now, what about this guy? Won't you be that guy and that guy? Only that guy and that guy, right? The number before and the one before that. What's this one? That. Does anybody know what this sequence is called? Because it's actually got a name.
That's the Fibonacci sequence.
It's called the Fibonacci sequence. It's a fascinating sequence. If you're interested, go looking online. It's connected to the golden ratio, which is another very interesting number. Plant branches branch very often according to the Fibonacci sequence, or at least certain branches, certain plants branches do. So it's found in nature, the Fibonacci sequence, and it's found in architecture indirectly, at least. Pretty cool. So we have 2 major ways to describe a sequence. Can't we do it with an implicit formula, right? And we've talked about them at the start. Isn't that one just plug in 1, plug in 21, plug in 1,000,000? You get the answer you look for. You don't need to worry about the ones that come before. Don't you only need to plug in the one you want? So if I wanted the 10th one, I put n as 10 and I'm done. Would you agree that in the Fibonacci or any of the recursion ones, don't you have to find all the previous numbers to get the one you're wanting? So you really don't want to do that for big numbers. They don't ask you in the homework to do it for big numbers. Are we good so far? Do you feel comfortable about what we've covered? Right. Let's pause a little while and go and look at the reality of what do the homework questions look like, right? So I'm going to move this fella and show you some homework questions. Now, if you've done WebAssign before, you'll know a little bit about how it works. Okay, I've got somebody in the chat. Should that be something I need to do? Yeah, someone mentioned it's a score pattern. They were right. Okay, pretty basic, no frills question. Wouldn't this guy be what we did at the start of today? Can you see how it works and how they ask you? If I want to do E5, it's 125 take away that guy, so it's what, 120? Right. If I wanted to do A2, it would be what, 3? Right, 2 times 2 times 2 take away 5, and I'd get all the others. Can you do that in your head or the calculator if you felt tired? I'm on a, I don't have that submit button because this one I'm doing is the kind of my version, so I don't get the answers unless I want them, right? So if I clicked on that, you'd see the answers, but I don't want you to do them. Now, have you seen the other way that they write the formula? You see the little curly brackety things. Have you noticed that it started at n equals 2 rather than 1? Couldn't tell you why, they just felt like doing it, right? There's no significance to it. And do you notice then that they want A2, A3, A5, and A6, right? Now, you could certainly do them one at a time. I think I would have problems by the time you got to 3 to the 6 plus that guy, which you could, that's a massively ugly answer, right? But you could do it. So are we comfortable with, we call these implicit formulas, right? That's an implicit formula. That's just a different way of saying it, right? Oh, let's try this one. I'm going to plug in 1. -1 to the power of 1, isn't that just -1? And 3 to the power of 1 is 3. So essentially that answer should be -1/3. And I just realized something. You won't see what I want. So I'm going to leave that and come back in a second. And how am I going to do it? I'm going to do it as a student view then. Just want to show you the buttons that you would be pressing to make that happen, right? So there's that guy again. So, well, oh, do you notice that the numbers that are in red change? So you might be doing question 3, Caitlin's doing question 3, but Thomas, you get 2 to the n and Caitlin gets 7 to the n. So you can't phone up Thomas and say, what did you get for question 3? And she should say, oh, I got this, and you type it in and it'll say it's wrong because the numbers change, right? So you have to be aware that your question is not really going to be, unless you're really lucky, the exact same question as anyone else. Right, back to this guy. When I click on that, enter a fraction, integer, or decimal. Okay, well, I want to do -1. And I'm going to do divide, and I'm going to do 5. And it never did what I wanted. I wanted that little box over there. Has I've done something wrong? No. Okay. Let's submit it. Okay. What I was hoping to see is, do you know that little box where you hit it and you can hit the fractions and make them look pretty? Evidently, it doesn't do it for every question, but we can live with that. Are we cool with that one? Just plug in 1, 2, 3, 4. Just looking at it, does anybody know very roughly, what does that sequence look like?
Can I say it is a unit circle?
All its values are connected to a unit circle, but what are the numbers that you get? What would you get if you did cosine of pi, for instance? You get -1. And then you would get cosine of 2 pi, which is 1. And then you get the cosine of 3 pi, which is -1. And then you get, well, you can see what's happening here. Isn't that a very boring sequence? But it's still a sequence, isn't it? Isn't it a list of numbers that have a pattern? The pattern is, well, it just goes plus and minus 1. Now I need to leave for a moment and show you an expression that you might not know. Some of you will, I'm sure, but not everyone. And there's a guy, a calculation called factorial, and it uses an exclamation mark. 5 factorial is 1 times 2 times 3 times 4 times 5, which is 120. 3 factorial is 1 times 2 times 3 is 6. Have you ever seen factorials? Do you recognize them, right? So the question that you can't see anymore looks something like this. This is its implicit formula. Now, if you want to do A1, it's -2 to the 1. 3 plus 1 is 4 factorial. That guy is -2. That's 4 times 3 is 12, 24. And of course, shouldn't you always simplify fractions? So that one is -12. If I do A2, it's -2 squared over 5 factorial, which is +4 over 120. But when you cancel it down, you get plus 130. Can you see that those guys are just going to be time consuming, right? You just have to do each one. Now, if you don't know all the factorials, like you might not know 7 factorial, and you could certainly do it. Couldn't you just go 1 times 2 times 3 up to 7 and get it? But there is a place where it's hidden. So let's suppose I do it. 7, math button, move over to probability. And you see option 4 has the little factorial. So that's where the factorial is hidden. Math over to probability number 4. And 7 factorial is huge. Now let's just say that you got 40 divided by 4050, right? Let's pretend that's what your answer is. You might not know that it can be simplified. If I plug that into a calculator, can you see that I get that weird decimal? But what you can then do is math button, choice number 1, and hit answer. Do you see it simplifies fractions? So TI-84 can be used to do really, can you imagine these could be massively big numbers that you might not know how to simplify because, 475 and 18,300, right? How on earth am I going to simplify those kind of numbers? Can't you just plug into the calculator, make it a decimal, and then turn the decimal answer into a fraction? And that's how you get around the simplifying These ones are easy, but can you imagine the next 2 or 3 are going to get horrendously messy. We cool with factorials? Anything else I've missed? No. So let me show you. I'll just tell you because it saves me going back and forward. This is a version of question 6. This is a recursive relation, and it's an plus 1 is 2 times an add 5, and they tell you a1 is 2, and the homework looks something like this in WebAssign. I won't do all of them, right? I'll do that many, right? Okay, that one there is a freebie, right? Because they told me, right? So I didn't need to do anything. Right, the next number, right, A2. Won't A2 be twice the previous number add 5? 2 times 2 add 5 gets me 9. Are you happy about where that came from? 2 times the previous number add 5. Okay, won't this one be 2 times the previous number add 5? So what's that? 18, that's 23. So 2, 9, 23, and so on, right? I would go with recurrence of relation type questions as well, what they look like and what's expected. Okay. So what's my next thing I want to talk about? We want to look now at questions about finding formula. That's a bit of a problem. If I give you a sequence like I did at the start of today, and I asked you to create a formula for it, that was the answer. Remember that question? That was the answer. Now, some of you got it, and some of you only once you saw the answer realized that it worked, but you didn't know how to create it in the first place. And that's because this is not a fixed process. It's not like solving an equation, right? Do this to both sides, divide both sides by 2, you know, that kind of procedure, right? You got to take these questions and kind of have a strategy rather than a process, right? A formula. So I'm going to show you 3 very common types. The first one is called an arithmetic sequence. So if sequences appear a lot or are very useful, and there's a whole family of them that are kind of the same kind of way that they get created, they very often get a name. Fibonacci sequence, right? It gets a name because it's important. People use it. You know, it tells them all sorts of cool things. An arithmetic sequence, let me show you one. No reason it starts with 1, it can start with anything. First question I'm going to ask you is, what's the next number? Because if you know the next number, it helps.
21.
Correct. What did you do to get 21? How did you know it was 21 and not 20 or 22?
Add 4.
Okay, that's what makes an arithmetic sequence an arithmetic sequence. You start with any number you like, but once you start with that number, you add the same amount, in this case, add 4, forever. Do you see that makes sense? Right, that's how that sequence. Now, how does that help me to create the formula, right? Well, here is an arithmetic sequence, an. It's made up of an a plus n minus 1 times d. You just memorize that. All arithmetic sequences can be created by using this formula, a plus n minus 1d. Now I have to tell you who a is. A is always going to be the first number. So in this case, isn't the first number 1? And d has a name. It's called the common difference. And in this case, wasn't it add 4 all the time? Right. So you started with 1 and added 4s. You started with 1, A is 1. You keep on adding 4, D is 4. So the formula is A plus n minus 1 times 4. And then you do a little bit cosmetics. And if you combine like terms, do you see you now have your arithmetic sequence? That's the formula that would generate this sequence. Wouldn't it be nice if we could check that it worked in case we screwed up somewhere? So the way I would check would just randomly pick a number. Right, so that's going to be A1, right? That's going to be A2, that's going to be A3, there's A4, there's A5, and so on. I'm going to pick A5. Well, according to my formula, shouldn't it be 4 times 5 take away 3, which is 20 take away 3, which is 17. Did that work? Yeah, means I got it right, doesn't it? So if you create a formula, check it, pick a random number, right? Pick the 4th number, find out A4, find out A7, whatever it is you're looking for, right? And if it matches, it's a great chance you've done it right. So if someone gives you a sequence and it's an arithmetic sequence, it will have the following features. It will start with any number you like, but then you will add the same amount each time. Is that an arithmetic sequence? Okay, how much am I adding to get from one number to the next to the next?
5.
So in this question, isn't A going to be 3 and D going to be 5? You see how you find those guys first? Now that means I can now create my formula for an arithmetic sequence. It's going to be 3 plus n minus 1 times 5, multiply by the usual rules, and combine like terms. Right. Are we cool with how you would generate the formula for an arithmetic sequence? Are you also comfortable with recognizing when you have an arithmetic sequence? Isn't it any number you like, but once you've got that number, you add the same amount every time? Isn't that the sign of an arithmetic sequence? Which means that you can use this to get its formula. So that is that guy done. Let's move on. Oh, can I move on? Are you cool with that? Okay, let's move on now to what's called the geometric, which is actually much more common sequence. Show you what a geometric sequence looks like. 10, 5, 5 halves, 5 quarters, 5 eighths. Have you noticed that this particular sequence, the difference between one answer to the next is different? Would you agree it's not an arithmetic? Would you agree that that difference is 5, but this difference is 2.5, right? They're different numbers. So it is not an arithmetic. What makes this? You're dividing by what?
By 2.
2. And another way of saying dividing by 2, because we want to think in terms of multiplication when you do these questions, is I want you to think of multiplying by a half. Right? That's the same as dividing by 2. I want you to think of it as multiplying by a half. So a geometric sequence has the property that you start with any number you like, and then you just continue to multiply by the same amount, in this case, a half. Let's show you a second one before we even worry about the formula. Suppose we have 3, 6, 12, 24, 48. Would you agree that in this situation, you start with a number 3, but once you've started with the number 3, what are you multiplying now by?
2.
2. So sometimes you can multiply by halves and thirds and 3/4, and sometimes you can multiply by 2s and 5s and 7s. And the third one I want to show you is this one. It is a geometric sequence. What are you?
You're multiplying by -3rd, right?
You are indeed. The number that you, or the fraction that you multiply each term by to get the next one, right? That number is called R, and it has a name, and it's called the common ratio. In this case, it was positive a half. In this question, it was 2. And in this question, it was negative 1/3. Are we good? Now, the first term is 10 or 3 or 2. In this question, the first term is also called A. So let me tell you the formula that will generate this geometric sequence. AN is going to be A times R to the power of n minus 1. So in this question, it's going to be 10 times 1/2 to the power of n minus 1. I know it's a pretty ugly looking formula, but that formula will generate this sequence. So notice what it is. It's the first number times the common ratio raised to n minus 1. You might have said, oh, why is it not n? Well, n doesn't work, but n minus 1 does. Are we good? Right. Now, I should check this one, right? So that's 1, that's 2, that's 3, that's 4, and that one's 5. Which one do you want me to do? A1, well, not A, A2, 3, 4, or 5. Which one shall I use as my check that I've done this correctly? Give me a number.
3.
3, okay. So if I've done it correctly, it should be 10 times, in brackets, 1/2 divided by 2. Agreed? 3 take away 1 is 2. And that there is the answer. And if I make that a fraction, hey, it works, doesn't it? Now, next one, you start with a 3. So it's 3 times 2 to the power of n minus 1. Are you comfortable with that formula? This one is going to be 2 times negative 1/3 to the power of n minus 1. Are you comfortable with that one? And where the bits came from? I'm not going to check those two. Can we just pretend that I've checked them because I know they work, right? But it's good practice in your homework to do a check, because you could. Oh God, WebAssign, I just thought of this. WebAssign makes you lazy. See if you got it wrong, won't it just tell you that you're wrong so you don't need to check it because you know you're wrong? But, you know, I would still check it anyway. It saves you using up one of your guesses. Now, I'm going to try and prove this to you. I'm going to try and prove that that is the formula for any geometric series in the world, right? And with a bit of luck, this will work. Now, I don't, a lot of the things that you're going to learn in this quarter, you're just going to have to trust me, right? I'm just going to tell you, trust me, I'm a mathematician, it works, right? An example of that isn't the formula for an arithmetic sequence. Trust me, it works, right? I just said use it, it works, right? Let's prove this one to you. Right, let's kind of write down, say, the first 4 terms of a geometric series, right? Well, the first guy is called A. Would you agree? Wouldn't that be any geometric series? The first guy is called A. How do you get the next term? Well, don't you multiply this guy by R? Agreed? So wouldn't this guy be called AR? Right? If you take the first guy A and you multiply it by R, wouldn't the second term be A times R? AR. Now, if you multiply AR by R, what do you get now? Well, you get AR squared. You agree? And if you get the next one, well, don't you just multiply it and you get AR3? Do you notice the connection between the position and the formula? So if I wanted to do a mysterious end, based on this pattern, would you agree that if the 4th one gets you AR cubed, wouldn't the nth one get you AR to the n minus 1? Have I proved the formula? Can you see the logic behind where that weird n minus 1 is coming from? So far, so good? I'm going to give you a ridiculously ugly geometric sequence. And the reason I'm doing it is I want you to have a method for finding the R, even when the fractions or the values here are really ugly fractions. So I'm going to start with 3/7. That's a nice easy one. And then I'm going to go . And then I'm going to get 5/7. I'll do it one more time. Then I get 125/63s. Now, you might not recognize this as a geometric series, but it is. The A value is easy because it's just 3/7. Could someone tell me the calculation, not the answer, but the calculation to find the common ratio R? How to get from here to here or from here to here, for instance? What would the calculation be to find R?
Multiply by 3.
Oh, you're trying to, well, no, I wouldn't say 3. I want to know the calculation that you would use, not the answer.
Can I propose a solution to this?
Mhm.
So could I use the first, 5/7 divided by 3/7, because geometric sequence have like, every one of them, if the next, the first and the second, if I divide by the first one, it still has the same one as the third and the second one.
Yes. So can I just paraphrase what you just said, essentially? If you
Agreed.
go from there to there, what you said is exactly correct. All you need to do is take this guy and divide it by that, because won't this calculation be what you multiplied this one to get that? Does that make sense? So if you take A2 and you divide it by A1, right? You have it. Now I'm going to put that horrible mess into a calculator and see what we get. Bracket 5/7 divided by brackets 3/7 and make that a fraction. And the answer was 5/3. So the person who said 3 was kind of half right, right? But the 3 was in the bottom, right? So if it is a geometric sequence, if multiplying from here to here is 5/3, won't it be 5/3 all the time? I think I could do this one. If you multiply by 5/3, can you see the 25/21 appear? Now it's less obvious, but if you multiply that by 5 and that by 3, can you see the 25 and the 63 happen? Can you see it now? Originally, if you just looked at those fractions, wouldn't it be kind of ugly and overwhelming? It's kind of hard to see fractions when they're not halves or when they're not whole numbers like 2. But that's how you would get round a geometric sequence like that. Are we good? Right. Which kind of makes me check off those ones. So the last kind, and you always keep the best till last, don't you? And this will be the last thing we'll be doing today, are the ones I'm calling general sequence. And basically that is everybody else. And when you get a general sequence, all bets are off. There isn't a formula. You just gotta look for a pattern. One, two, three, four, so on. Not everybody's brain is the same, so I'm showing you how my brain works when I see this. First thing I notice is that the answer's a fraction. So would you agree that the formula is probably going to have a fraction to it? I notice that everybody in the top is 1, so there's a good chance the top's 1. I then only focus on the bottom, and I'm looking and I'm saying 2, 3, 4, 5. If 1 gets you 2 and 3 gets you 4 and 4 gets you 5, then I just need to figure out, what does n get me? Because whatever I write here is the formula. Okay. If 4 gets me 5, right? 2 gets me 3, what would n get me? What would go in the bottom?
N plus 1.
Let's try another one. You either see it or you don't. There's not any shortcut, at least none that I know of, that would make that obvious. But does anybody recognize it?
Are they being cubed?
It is n cubed. What would that be?
Is that the reverse of the previous one?
Yeah, just 1 over n cubed. What would that get you?
Same thing, but you just time 10.
Yeah. Try another one. Where should we go with this one? Would you agree it's a fraction and 1 is on the top? So we don't need to worry about that. We need to figure out 1 gets you 6, 3 gets you 18, 2 gets you 12, 4 gets you 24. What the heck are you doing to the green number to make the bottom number happy?
Multiply by 6.
And to write that down, we would call that 6n, wouldn't we? Suppose someone did this to you, which is probably the worst thing they could do to you. How could I use this answer to get that answer?
Multiply by 6 and add 1.
And we call that 6n plus 1. If you look at a sequence and the bottom numbers have a pattern to them, and that pattern ends up being an arithmetic, can't you do the formula for the arithmetic on the bottom and have 1 over that formula? If the thing on the bottom is a geometric series, right? 1 over this, 1 over this, 1 over this. If it's a geometric series, can't we just do 1 over the formula for the geometric? So we can actually sometimes get away with that type of situation. And we are about to take attendance, which is part of your participation. So the way that we do it is if you go to, let me click off this for a second. If you go to the chat, right, see a little bubble thing, and put your last name there. So in Jarrett, you're going to put Megler in. You're going to put Coleridge and so on. Did I teach somebody in your family? Who did I teach? Who's the Coleridge in your family I taught, Thomas?
You taught 3, actually.
God, 3?
Yeah. There's
3?
Micah, Johan,
Right.
and James.
You think they would have warned you by now?
Oh, they told me all about you.
And yet you still took me?
Yeah.
Okay, it's your own fault then. You can't say you weren't warned. Is there any more of you in the pipeline? Because I'm going to be retiring soon. I want to make sure I get through the whole family. Is there anybody else after you?
Maybe. It depends.
Okay.
There's
Well,
one.
it depends on your experience and whether this worked or not. Okay. Right. If you've done that, guys, it's bye-bye. Have a nice evening. I'll hang about for any questions. If not, then I'll see you on Tuesday.
I had one question.
Yes.
So how did you, what was that? So on the first page of your notes,
Ooh, that's a long way away. Let me see. A little bit more detail. What was on my first page? Was it an arithmetic sequence or was it before that?
you're showing how
Well-
to do a calculation on the calculator.
Oh, that one. Okay.
Just wanted to see how that's done.
Okay. So basically, I can just show you on my calculator again. Would that work?
Mhm.
Okay. So let me go back to the white thing and show you. Let's pretend that I wanted to do the first 5 terms and the sequence was called n squared plus 1 over 2 to the power of n, right?
Okay.
Okay, so you go to your calculator and you type in y equals, and you put this fella into y1. So I go a bracket, I'll have to call it x, so it's x squared plus 1, close the brackets, divided by 2 to the power of x. So that's 2 to the power of x. So you type the formula in. If you've done the table set up once, you don't need to do this anymore, but let's pretend we haven't. So you do second button, the window one called table setup, and you make sure it starts with a 1 and the delta goes up in 1. And most importantly, make that ask. Make sure that says ask. And now we can just go second table. And I'm going to delete all of them because that was from a previous question. And A1, A2, A3, A4. Now I'm going to be getting some decimals out of some of these, but we'll show you how to fix that in a minute. Right, so I want to know A1, you plug 1 in. Oh, that was an easy answer. You want 2, you get 1.25. You want 3. There's a surprise. 1.25 again. You put in 4. You get 1.0625. And finally, you put in 5 and you get 0.8125. Now, we don't like decimals, so I'm going to take each of these decimals and find out what they are as a fraction. So 1.25, you could probably figure that out yourself without this. Let's clear this out. So 1.25, as I say, you could probably do that in your head, but there's a button for it. It's 5 quarters. And since that's the same one, that's 5 quarters. This one, 1.0625. Math button, choice 1, which basically says take the answer and make it a fraction. And we get 17/16. And then the last one, 0.8125. And do math button, choice 1. And we get 13/16. Would you agree that's pretty fast? I mean, it's a lot easier than trying to do each question as a set
Mathematical way.
calculation.
Yes.